The University of KwaZulu-Natal's College of Agriculture, Engineering and Science is committed to making a difference in our world, from the classroom and laboratory to the field. It provides one of the finest study and research environments on the African continent and is recognized internationally as a center of excellence. Agriculture, Engineering and Science is one of 4 colleges that make up the University of KwaZulu-Natal and is home to over 8,700 students and approximately 700 staff. 3 of the university's 5 campuses form the core of agriculture, engineering and science activities in the region. The college comprises 5 schools: agricultural, earth and environmental sciences, engineering, chemistry and physics, life sciences and mathematics, statistics and computer science. Engineering is offered on the Howard College campus, agriculture on the Pietermaritzburg, and all the other sciences on both the Pietermaritzburg and Westville campuses. Exceptions are agricultural engineering, which is offered in Pietermaritzburg, and geology, which is offered at Westville only. To compete with the best and to meet the challenges of the 21st century, South Africa needs highly skilled professionals in the areas of agriculture, engineering and science. We offer a wide array of interesting and innovative degree programs that open doors to a variety of different careers. Some degrees are unique to UKZN and are not offered at other tertiary institutions. For example, we are the only university in South Africa to offer a fully accredited agricultural engineering degree and one of only 2 universities in the country to offer a BSc in land surveying. Our postgraduate food security training program is the only one in the world, and we have the widest range of agricultural disciplines at any single South African or African campus. The choices of degree and the options on offer may seem confusing at first. Engineering degrees are more specific, and the options are usually career-focused. Emphasis is placed on training in the specific principles which engineers deal with in their professions. Engineering offers 7 different professional specializations. There are also degrees in land surveying or geomatics and property development. In science, there are structured or career-focused degrees. These include fields as varied as chemical technology, marine biology, industrial and applied biotechnology, and computer science and information technology, to mention a few. There are also more general degrees with a lot of flexibility. In this case, students have the choice of studying a BSc M stream in maths, physics, computer science, and statistics. All of these have a strong mathematical component. The other option is a BSc LES stream with a focus on the life and environmental sciences with subjects such as geography, genetics, botany, hydrology, zoology, ecology, and microbiology. In agriculture, there are various different options that involve practical and scientific applications. Students can combine science subjects with specific agricultural disciplines for a 4-year Bachelor of Science in Agriculture degree. These are more career-orientated. Agriculture and agricultural management are 3-year degrees with a higher practical component. Dietetics is a professional qualification that deals with the role nutrition plays in the promotion of health and the treatment of disease. Most degree programs across the college have field trips and projects that contribute significantly to the curriculum. This ensures that students learn in real-life situations under full field conditions. Many of our lecturers have received Excellence in Teaching awards, are recognized internationally, and are rich in practical experience. Students have access to excellent facilities that rank amongst the best in the world. 300 million rands has recently been invested in new teaching and research facilities, state-of-the-art laboratories, and improved equipment. The 30 million rands new School of Engineering building is the envy of engineering campuses across the country. Agricultural students have access to a 356-hectare research and training farm situated near the Pietermaritzburg campus. This facility provides students with hands-on training and is used extensively as an outdoor laboratory for teaching and research in areas such as animal and poultry science, horticultural science, and agricultural engineering. Adjoining Ukulinga is the Bisley Valley Nature Reserve, which supports a diversity of plant and bird species, as well as some large mammals. It provides a rich learning and research environment for staff and students. Based on the Westville campus, the college possesses unique facilities for research into higher voltage power transmission. These facilities are available in only 3 other places in the world and form part of the ESCOM-sponsored Science and Technology Innovation Park. The Science and Technology Education Center showcases the college's scientific achievements and promotes the public understanding of science, engineering, and technology within the region. The college houses a wide range of sophisticated equipment in its microscopy and microanalysis units, staffed by highly qualified and skilled technical specialists. The College of Agriculture, Engineering, and Science prides itself on its graduates who are highly sought after. In a market characterized by a shortage of qualified professionals in science and technology, our graduates are readily employed around the world in the fields of agriculture, science, commerce, industry, engineering, and research, to name just a few. Research plays a major role within the college and operates at the cutting edge of technology. The college has the highest research output in the university and produces the most research publications. There are over 60 well-established research groups and centers within the college. The African Center for Crop Improvement caters for students from all over Africa. It is one of only 2 African plant breeding programs on the continent. Based in the School of Agricultural, Earth and Environmental Sciences, the African Center for Food Security focuses on alleviating hunger in Africa. It offers food security training programs, undertakes academic and applied research, and provides policy and program support. Promoting sustainable engineering practice is the Center for Research in Environmental, Coastal and Hydrological Engineering, or CRESH. It deals with the interaction between engineering and the natural environment. The Mechatronics and Robotics Research Group in the School of Engineering provides an excellent research and education environment for its senior undergraduate and postgraduate students. Judged one of the best research centers at the university, the Center for Plant Growth and Development focuses on high-quality research in the plant-based disciplines of plant physiology, plant molecular biology, and ethnobotany. The Center for Quantum Technology deals with physical phenomena at the microscopic level. Quantum physics led to the development of the transistor and the laser and is currently being used to develop quantum computers and quantum cryptography. The college is committed to access and readdressing the disadvantages and inequities of the past. The highly successful Unite Engineering program and the Science Access Foundation and augmented programs offer alternative access to university, equipping students from disadvantaged backgrounds with the skills and knowledge to pursue their degrees of choice. Both these programs contribute significantly to advancing Black African scientists and engineers in South Africa. Staff and students contribute to a number of outreach and community initiatives that focus on social responsibility, sustainable development and upliftment of the wider community. The college also engages in activities involving the pursuit and understanding of science, engineering and technology through exhibitions, festivals and roadshows that target high school learners and the general public. The college has minimum entry requirements for its programs. These differ from degree to degree, but all require a national senior certificate and minimum performance levels in mathematics and either physical or life or agricultural sciences. For those who do not meet the minimum requirements, access programs are available. Additional information and brochures can be obtained from the contact information accompanying this video. The College of Agriculture, Engineering and Science is proud of its contribution to the university, the region and the country.
UKZN is one of the best. I definitely understand it's one of the best in South Africa. So for me, there was no other institute that I would have preferred other than UKZN.
We have the best facilities here in terms of laboratories, in terms of equipment, in terms of human resources, in terms of literature.
UKZN is one of the best universities in the country that teach agriculture or natural sciences.
What I think is good about this college is the level of international collaboration that we have. We have friendships with universities all over the world, which means that we're keeping up to a great international standard.
UKZN has got much more facilities and it's recommended worldwide to do your science studies here. Life begins here. Yes.
We continually strive to be academically excellent, innovative in research, and critically engaged with society. We invite you to join us or work with us to be part of this exciting team.
Okay, Shan, you can go ahead and start. Thank you.
Morning. Hi. What have you know?
Hi, Shan. Are we ready to begin?
Mute, unmute. And oh, good morning, students. Yesterday we discussed sequence, series, and sigma notation. We will do a few examples and then go on to calculus maxima and minima. For sequence, series, and sigma notation, I will select a few examples so we can spend more time on calculus. Question 2.1, 7xy minus 11 is an arithmetic sequence. Determine the values of x and y. Okay, now you notice we use semicolon, 7 semicolon x semicolon y, and the fourth term is minus 11. So that is how a sequence is written. But when we use the symbol sigma, example in question 3.1, and when you generate the terms from there, you use the plus sign. Sigma means find the sum of the terms generated in that, we'll call it series. So that's the difference between sequence and series. take note that mathematics is a very technical language. It's a language on its own. Sequence, the terms come to mind are sequence, series, sigma notation, derivatives, infinity. So make sure you have a good understanding of the various concepts. Right, so I'm going to select a few problems in this section. Let's call it number patterns. So we start with a very simple one. 7x y minus 11 is an arithmetic sequence. Find or determine the values of x and y. Right, let's look at the first one. No, that is okay. So we have 7 x, y, and minus 11. These are the first 4 terms. Remember, we also say the first term is 7, second term x, third term y, and the fourth term minus 11. So you have T1, T2, T3, T4. As I pointed out yesterday, you need to know all your formulas. T4 is A plus 3D, which is minus 11. T1, we can use A or let A equal to 7. Now we need to find x and y. Okay, so if A plus 3D is minus 11, but we know that A is 7, so you can solve for D. That's easy, simple. 3D is equal to minus 11 minus 7, which is minus 18. Dividing both sides by 3, you get D equal to minus 6. So now you can work out x. Remember, T2 is x, which is A plus D, that is 7 minus 6 equal to 1. T3 is y, which is A, okay, T3 is y, which is A plus 2D. But also remember, if you got 7 and add minus 6, you get 1. Add minus 6, you get minus 5. Okay, so another thing to consider is this problem can be worked out in many different ways. And it's important to know the different ways of doing it. It will enhance your mathematical abilities. And remember, mathematics is about practice and doing things the right way and getting the correct answer. So remember, there's very little margin for error. The moment you make an error in the first, second step, then you will encounter difficulties. So it's very important that you work as accurate as possible. Okay, there are several ways of doing this. You can say 7 minus x is equal to x minus y. So you got an equation x and y, and that will be 2y equal to 7, sorry, transpose that 2x equal to 7 plus y. Transpose the y onto the left-hand side, transpose this x onto the right-hand side. So you got 2y equal to 7 plus x. So you can set up several equations and you can solve them. Now that's an easy one. And when you're writing exams, it's so important to start with the easy ones, get them right, build your confidence, and then you can go on in a good frame of mind. The next example I chose was a quadratic sequence. Now, if you got It's a simple one, but use this to practice to see what a quadratic sequence involves. Right. Number one, you got to find the common difference twice. 5 minus 2 is 3, 10 minus 5 is 5, 17 minus 10 is 7. So you got 3, 5, and 7. Now find the difference again. 5 minus 3 is 2, 7 minus 5 is 2. So you can see that when the second difference is a constant, then this forms a quadratic sequence. It's a very interesting one. When I was in school, we only spoke about arithmetic, geometric, and maybe a bit of sigma. But this is more interesting. Now, what we want to do is find the general term of the sequence. Now, here, from the term quadratic, y equal to, or the expression ax squared plus bx plus c is the quadratic expression. Y equal to, or f of x equal to ax squared plus bx plus c is the quadratic function. So here again you see this terminology, but don't stress too much about that. Right, so you got Tn equal to an squared plus bn plus c. Now for T1 you substitute n equal to 1. So you got a plus b plus c. For T2 you substitute n equals 2. 2 squared is 4. So you will get 4a plus 2b plus c. And similarly, for n equal to 3, it will be 3 squared, 9a plus 3b plus c. Now go back to the question, the original sequence. The first term is 2. Therefore, a plus b plus c is 2. The second term is 5. So 4a plus 2b plus c equal to 5, and so on. 9a plus 3b plus c is 10, which is the third term. Now you have a system of equations in 3 variables, a, b, and c. Number the equations 1, 2, and 3. So if a plus b plus c is 2, equation 1, 4a plus 2b plus c is equal to 5. That is equation 2. Now, when you subtract 5 minus 2 is 3, c minus c will cancel, and 2b minus 1b is b. 4a minus a is 3a. Students, it's important for you to have a pen and paper handy so you can just follow and do this calculation. So what you have is 3a plus b equal to 3. And do the same for equation 2 and 3. 10 minus 5 is 5. 3b minus 2b is b. And 9a minus 4a is 5a. So now you have 2 equations in a and b. And if you do the subtraction again, you now eliminate b. So you get a equal to 1. And similarly, you can work out the rest by substituting for a equal to 1, and you will get your values of b and c. Now, let's try and look at the the terms 2, 5, 10, and 17. Okay, the general term now becomes the n squared plus 1. You could have guessed the answer there. 1 squared is 1, plus 2, plus 1 is 2. 2 squared is 4, 4 plus 1 is 5. 3 squared is 9, 9 plus 1 is 10. 4 squared is 16, 16 plus 1 is 17. So this quadratic sequence is based on the perfect squares of the natural numbers. Okay, so that's an arithmetic. There's a quadratic. Next, we look at something on sigma. We'll just do 2 more on this part of the presentation. Well, we had arithmetic. The 4 things you need to understand is arithmetic, geometric, quadratic, and this involves sigma notation. And here you see convergent geometric series. There's the term convergent geometric series. So what you have here is to prove that sigma 4 times 3 to the power 2 minus k, where k equal to 1, and there are an infinite number of terms. So this is a sequence to infinity. And you obtain the terms by substituting, you start by substituting k equal to 1. Now if k is 1, you get 4 times 3 to the power 2. 2 minus 1 is 1. So actually the first term is 12. If you substitute k equal to 2, you get the second term. 2 minus 1 is 1. Substitute k equal to 2. 2 minus 2 is 0. 3 to the power 0 is 1. So the second term is 4 times 1, which is 4. So remember, the first term was 12. The second term is 4. So you don't need, we know it's geometric. So how did we get from 12 to 4? You divide by 3. So the next term will be 4 divided by 3. Let's check. For k equal to 3, you get 2 minus 3, which is minus 1. 3 to the minus 1 is 1 over 3. So that's how you get your 4 over 3. So the sequence now is 12, 4, and 4 over 3. Okay, and it's clear that your constant ratio is 1/3. So you multiply each term by 1/3 to get to the next term, or divide each term by 3. 12 over 3 is 4, and 4 over 3, 4 divided by 3 is 4 over 3, and the fourth term will be 4 over 9, dividing by 3. Now your ratio there is 1/3. Now when your ratio is 1/3, so it becomes convergent. And that is if your R lies between 1 and minus 1. So it's convergent. We'll get back to that because I want you to look at these two together. Now, what is different from these two? They look very much alike. Sigma, infinity, infinity, k equal to 1. But here, k is equal to p. In 3.1, we substitute k equal to 1 to get the first term. But in 3.2, you must substitute k equal to p to get the first term. So the first term is 4 times 3 to the power 2 minus p. That's the first term. And the sum of the terms to infinity is equal to 2 over 9. So you determine the value of p. Okay, as I discussed in 3.1, we found that the terms are 12, 4, and 4 over 3 by substituting k equal to 1, 2, and 3. So it's clear that your ratio is 1/3. And if your ratio is between 1 and -1, then it is a convergent geometric series. Why I use series? Because of the sigma notation. Now, why you need to write these steps is you get marks for showing all working details. If you just said r equal to 1/3 without any working, you work it out in the end, which is easy to do. You'll get 1 mark. You need to show all the working details. For a convergent geometric series or sequence, the ratio must be a fraction. It must lie between 1. It must be less than 1 and greater than -1. Now we look at the last question, which is sigma 4 times 3 to the power 2 minus k, starting with k equal to p, and there are infinite number of terms. But the sum to infinity is 2 over 9. Okay, so we already know that the r is equal to 1/3. And the first term, where k is equal to p, will be 4 times 3 to the power 2 minus p by substitution. And once again, we come up with a formula. Sum to infinity is a over 1 minus r is equal to 2 over 9. A is equal to 4 times 3 to the power 2 minus p over 1 minus r. R was 1/3, so your denominator is 1 minus 1/3, which is 2/3. Now you cross multiply 2 over 9 times 2 over 3, you get 4 over 27, and and p is in an exponential form. So you have an exponential equation here, an equation in exponents, and it's easy to solve this one. 3 to the power 2 minus p is equal to 4 over 27. Let's divide that by 4. So you have powers of 3. Now 27 is equal to 3 times 3 times 3, which is 3 to the power 3. So 1 over 27 will be 3 to the minus 3. So 3 to the power 2 minus p is equal to 3 to the minus 3. So the equation now becomes 2 minus p equal to minus 3. If the bases are the same, you simply equate the exponents. So you can see clear that it's clear that p is equal to 5. Okay, so that covers number patterns, which are, there's 4 components there: arithmetic, geometric, quadratic, and sigma notation. Make sure you do as many as possible, practice and get them right. The next part, I'm going to focus on calculus. Why do we study calculus? What is important? Why should we even look? What's the value of it? We've got graphs. Let's look at this cubic function. Stationary point. This is at x equal to minus 1, you have a relative minimum. At x equal to 2, you got a relative maximum. How do we find stationary point? We let the derivative equal to 0 and solve for x, and we substitute to get the y values, corresponding y values. So those are stationary points. Okay, and the cubic function represents a very nice picture of graph. And here you have 2 stationary points. If you have y equal to x cubed, you'll get 1 point, which is a point of inflection. So you can get 1 point, you can get 2 stationary points, and you could also get 3 stationary points. I'll come back to that. The purpose of studying calculus for me is one, that you can solve problems on maxima and minima. I'll give you an example. There's an example on maxima and minima. So I think the focus of this morning session is on solving problem involving maxima and minima using calculus. In problem solving, you need to read the question, understand, draw diagrams, or draw graphs, or draw sketches, or draw tables. So there are many aspects to problem solving, and problem solving is vital for especially for a student at university, no matter what you're studying. And you can apply some of these strategies in life to solve problems that affect our communities and human beings. Example, climate change. It's causing havoc, destruction because of the rise in temperatures. What can we, surely we can do our bit to control climate, the rise in temperature. Well, I'm not going to go there. We know, we went through the experience. KZN was worth it. Okay, basically, calculus we're going to focus on maxima, minima. And problem solving is a vital aspect of life which we should all be engaged. Okay, read this question a few times so you know what's going on. A closed rectangular box has to be constructed as follows. Well, we talk about length, breadth, and height, or length, width, and height. It's a three-dimension. Three-dimension means length, width, and height. If it's two-dimensional, example, a rectangle, length times breadth, two variables, two dimensions. The length of the base is 3 times the width. Now, you must construct the box so that the volume is exactly 5 meters cubed. The material for the top and the bottom costs 15 rand per square meter, and the material for the sides costs 6 rand per square meter. Show that the cost to construct the box can be calculated by cost equal to 19W squared plus 48WH. Determine the width of the box such that the cost of the box is to build a box is a minimum. Right, so we need to understand the concept minimum, why minimum, and when maximum. Okay, so that is a picture about the box. We want to build it, construct it so that the volume is 5 meters cubed, but it has to be built at a minimum cost. We will examine that later. You're further given that the length is 3 times. So we can take all these facts into account. Right, so before we solve that one, let's do a problem to understand the concepts involved in maxima and minima problems. There are literally thousands of such problems. So let's do as many as we can. And I think it's a very useful exercise. As I said, I'm going to start with a simple problem. A farmer has 100 meters of fencing. Okay, I didn't know this. Let's see. No, skip that. I was trying to maximize this, but what's happening is, okay, let's see. I'm trying to maximize it, but part of the text is, okay, we will get back to that. Now, the farmer has 100 meters of fencing to enclose a rectangular plot along a river. Find the maximum area of this enclosed plot. Now, this jagged line here, wavy line, represents the river. Okay, so the farmer would be foolish to put fencing there, because if it rains and there's heavy flooding, that fence will disappear, will collapse. So, well, the choice is yours, farmer's choice if you want to. But this farmer decides, okay, I'll use the riverbank as, or maybe if he has cattle, cows or sheep, they can just go into the river and get back. All right, we won't go there. This enclosure is constructed such that it's X by Y, it's rectangular. And remember it has 3 sides. Now there's 2 concepts here are fencing. 100 meters of fencing from there to there, along that and back to the river. So that is your perimeter. So here we're looking at perimeter and area. The perimeter is x plus y plus x, which is 2x plus 2y, sorry, 2x plus y, which is 100. That's a perimeter. We'll call that 1. The area is x times y. Strictly speaking, it has to be closed, but it's in the shape of a rectangle. That's fine. And remember, if you've got 3 sides, you cannot say the area is x times y if one side is missing. That area can be infinite. But using the river bank as one of the sides, so the area is x times y. But from the perimeter, you can see that 2x plus y is 100. So y, subject to formula, y is equal to 100 minus 2x. So you substitute in x times y, which is x times 100 minus 2x, which will give you 100x minus 2x squared. Now let the area A of x equal to minus 2x squared plus 100x. The derivative is minus 4x. 2 times minus 2 is minus 4. Using the power rule, nx to the n minus 1. And that is 100. Let the derivative equal to 0. Now let's pause here and find why. Remember, when we draw the cubic function, we find the derivative, let it equal to 0, solve, and use those x values to determine the maxima or minima values of the turning points. Therefore, the same principle applied. Derivative equal to 0. You get minus 4x equal to 100, so x is 25. So if x is 25, so y must be, that's 25, 25 is 50. So y has to be 50 to give a perimeter of 100. So the maximum area is 25 times 50 meters squared. And you can multiply that out, which is 250 times 5, and that is 1250. 5 times 0 is 0, 5 5 is 25, 5 2 the 10 to 12, 1250. Right. I don't have a calculator, I don't use a calculator, but you are welcome to do that in the exam. Now we don't stop there, so the maximum area is 1250. Now this is a very important point to check. I'll give you a very simple technique. Remember the function y, f of x equal to x squared, or y equal to x squared. The derivative is 2x. The second derivative is 2 plus 2. When that happens, when the second derivative is positive, we are dealing with a minimum value. And you know the shape of the graph? It's like that, arms pointing upward. Now g of x is equal to minus x squared. The first derivative is minus 2x. The second derivative is minus 2. So this is, remember this principle. And you know the graph, the arms pointing downwards, minus x squared. So when the second derivative is negative, we are dealing with a maximum value. So that explains why this area is a maximum. Okay, now the other example we discussed was the box. Let's look at oh, here's a picture. I just try to, now what I'm using here is called a Sketchpad. You can draw diagrams, you can draw graphs, and you can use labels, you can color, etc. Okay. Now this is a closed box. The box is, there's your length, that's your width, and that's your height. Okay. That's your height, that's width. Okay. So the volume is equal to length times breadth times height, or length times width times height. And we know the volume is 5 cubic meters. But it's given that, if you recall, the length was 3 times the width. So what we'll do is we'll replace the L by 3W. Okay, let's say they are same. W is a bit smaller. Okay, so they're same size. So the width or the length is 3 times that. Therefore, the volume is 3W times W times H, which is 3W squared H. And the volume is equal to 5. It means that 3W squared H is equal to 5. Now this is a closed box. So the closed box is made up of the top and the bottom, which are identical. And the top and the bottom will cost you 15 Rand per square meter. The top and bottom, and the sides will cost you 6 Rand per square meter. So you have top and bottom, the front and the back, and the left side and the right side. So you cut the box up, you will get 6 pieces. Right, that's a picture that you have. It's not that one. Let's go to this one. Not that. Why am I? Right. Now let's quickly complete this. Right, I discussed the picture and gave you all the dimension, the cost, etc. If you recall, we said the volume is equal to 3W squared H. Volume is equal to, okay, I use X and Y, it's not a problem because X is replaced by W. 3W, okay, the volume is equal to 3W squared H. But remember, the volume was equal to 5 and H times W times 3W was equal to 5. So you make H the subject of the formula. I think that's important. Let me just go back to that. This volume, I'll tell you why that's important. The volume is 3W times W times H, which is 3W squared H equal to 5. And you make H the subject of formula, it'll be 5 over 3W squared. Now, why is that important? And remember, you're working with, okay, let's look at let's look at let's say y equal to x, let's say 2x or 2x squared plus 3x. So you have two variables, x and y. But here, strictly speaking, volume is equal to length times width times height, or length times breadth times height. There are four variables. Now, we are familiar with two variables when we find the derivative. And the very important principle is when y equal to something, y is subject of formula, then you can say dy dx. But if you've got y squared, then you need to take the square root and then proceed. So volume equal to length times breadth times height, and your volume is equal to 3w squared h. Okay, you got from 4 to 3 because the length was 3 times the width, so that's why you got 3 variables. Further, you need to reduce this to 2 variables, that is v and w, preferably. So you substitute for h equal to 5, h is the volume is 5, so h is equal to v over 3w squared, which is 5 over 3w squared. Now you substitute and get the cost equation. Right, and now let's find out how that comes about. The top costs 15 rand per square meter, and the bottom will also be the same. So the cost of the top and bottom is 15, and the cost of the sides, the 4 sides, is 6 rand per square meter. So note there's a difference there. Now, so let's quickly work this one out. What is the area of the top? I think we need to look at that again. All right. Remember, we are working with rectangles, right? Let's look at the top. The top is 3w, the length, by w, which is 3w squared times 15, which is 45. But the cost is the same for the bottom. So that will give you your 90 w squared. Now you work out the cost of the sides. Which this is, this side here is 3w times h times 6, and the front, the back will be the same. That's 3wh times 6 times 2 will give you 6 times 3, 18, times 2, 36. And this side here will be, the side is w times h, and same for the other one, which will be 2wh, which will be 12. So that will give you 6 times 2, 12wh. So your 48 and 12 will give you, 36 and 12 will give you your 48. Okay, so that fortunately this is given, so you work toward it and show that is how you arrive at 90 w squared plus 48 hw. That's your cost equation, and your h is equal to h is 5 over 3w. And if you simplify that, you will get all in terms of w, which is 90 w squared plus 80 w to the minus 1. 80 over w, or 80 times w to the minus 1. Now you find the derivative. And the derivative is c prime w, which is 2 times 90 is 180 w minus 80 w to the minus 2. You can work that out. And the standard rule is when the derivative equal to 0, you solve that to either get maxima or minima. Right, so you have an equation 180w minus 80w to the minus 2 equal to 0. You can multiply by w squared. You can divide by 10 and then further divide by 2. So you'll finally end up with 9w cubed equal to 4. So w cubed is equal to 4 over 9. So w is equal to the cube root of 4 over 9. Sorry, that's not 2, it should supposed to be 4. Right, so you have the cube root of 4 over 9. Let's correct that. So that is what was required. Well, they didn't ask you to. If you find the second derivative, you'll get your 180. And here, your second derivative will be minus 2 times that will give you minus plus 160 times w to the minus 3. Right, and finding the second derivative, and you obviously have to substitute to show that it's positive to get you a minimum cost. But as explained above, when the second derivative is positive, you're dealing with minimum and hence minimum cost. Okay, so it's clear that these word problems are time consuming, but they are very important. And please do a few examples, practice them so that you can score marks in the exam. Okay, so that concludes the first part of this morning session. Shall we have a break of 5 minutes and then we'll continue. Are there any questions at the moment? Right, we're having a break for 5 minutes. Hello. This combination thing. Um, combination. Oh, okay. Hello. Hi. I just had a 5 minutes break. How do I get back to the Zoom? Um, no, I didn't log off. It says stop sharing. There's one. Then, what do I click? The mute. That green, isn't it? But at the it says sharing your screen. Stop sharing or hide. Okay, I'm not getting a response from the other side. There's only 3 participants. Mute. It says mute. You carry on. When I click on mute, it's supposed to unmute, isn't it? Sorry? Okay. I'm not sure who. Yeah. Sorry? I'm not sure if they can hear me. There's Rachel there. I don't know how to get to.
Yeah, we can hear you.
Okay, sorry. Fine. Apologies for that. I'm not so technically savvy, but anyway, thank you. Let's continue. Right. We're going to go back to Sketchpad. I'm going to go to a new page. 7th of March. This is 12th of May. Okay. Okay. Now, a picture gives you, says a lot about graphs, the key points, and it's so important to check your answer. Let's say you're given the function f of x equal to x plus 1 times x minus 3 times x minus 4. That's a cubic function. So if you let f of x equal to 0, then your roots are 4, 3, and minus 1. And from the graph, you can see that the x-intercept is 4, 0, 3, 0, minus 1, 0. And if you multiply that out, your constant there will be 12. So for x equals 0, y is 12. So that's your y-intercept. Your x-intercepts are 4, 0, 3, 0, minus 1, 0. And the function increases from the left up to the stationary point. Right, so the function increases from the left okay, let's stop there, up to the stationary point. So that is a local maximum. Then the function decreases up to the okay, let's go back to it. So that's your local maximum. There's a decrease in the function up to this point here where there's a local minimum, and once again it decreases. So the key points are the x-intercepts, 3, and multiplying out your y-intercept, and find the derivative let it equal to 0. You'll get your 2x value for your, when x is, well, it's a fraction, I think. I didn't work that out, but so that's your, okay, let's give it a name. Let's call it A, and B. Okay, so B is your local minimum or relative minimum, and point A here is a relative maximum. Now, I discussed yesterday why local maximum, local minimum. if we say that the maximum value is minus 13 point something, but you can see that this graph goes up to positive infinity. So at points A and B, we refer to them as local maxima and minima. Right, so the other one. I'm looking at this function here. Okay, we can get to this one. Let's see how we can. Right, the first one, I'm just trying to continue from where we left yesterday. So we have, this can be written in a form, f of x equal to x minus x1 times x minus x2 times x minus x3, because there are three roots. And your general cubic function is f of x equal to ax cubed plus bx squared plus cx plus d. So there are basically three forms. Now, we're going to look at the other one, which is, let's hide this. Let's try to see, let's try to work out the equation of this graph. It's also cubic, but you notice it cuts at the x-axis at -3, and at the point 1, 0, the graph is a tangent to the x-axis. So what we have here is let's say, okay, it's too big now. Let's go to x let's say x is equal to 1 in one case, and x equal to, at this point is -3, x equal to x equal to -3. Right, let's reduce the size of this to 16. Too small. Okay. Right, so we have x is equal to 1 and x equal to -3. Right, so what we can say here, there are two roots here, because the graph is tangent at x equal to 1, x equal to -3. Now let's use this to form a cubic expression. So what will that be? Let's make it x minus 1 all squared times x plus 3. Let's try that. I had it somewhere. Now a new function, which is x plus 3 times x, say, minus 1 all squared. Okay, so now we have a new function. Let's say, okay. We have a new function which is h of x equal to x plus 3 times x minus 1 all squared. X minus 1 all squared because the graph is a tangent, the turning point here. The graph is a tangent to the x-axis. Right. Now I'm going to plot this function. Oh, can you see it? So this graph represents the function h of x equal to x plus 3 times x minus 1 all squared. Now, this graph cuts the y-axis at 3. Now, if you expand it out, it's easy to see that you're going to get plus 3. So when x is 0, y is plus 3. So this point here is the y-intercept 0 and x is 0, y is 3. So what is important is you have your general cubic function, and I've given you two examples where you have 2 roots, and there you have 3 roots. Now we can get a question. Well, look, you find the derivative letter equals 0, and you can get your turning points there. This is a minimum value, minimum turning stationary point, and that will be the maximum, relative maximum. We discussed that. Now, what happens if we make this x minus 3? What will happen to this graph? Now, if we expand this, and let's say you multiply by minus 1, you can be asked a question. If h of x is equal to the left-hand side multiplied by minus 1, what are the stationary points? Let's see what happens graphically. So what we are doing now is saying minus times minus into x plus 3 times x minus 1 Right, so can you see now the right-hand side is multiplied by minus 1. So the first example, you got positive x cubed, and the next one is starting with the negative x cubed. Right. Isn't that interesting? Okay, so that was our original function. Why is it? Oh, I think there's two graphs there. Okay, nevertheless, there's our new function. function is, let's give it another color. Right, I think that's a little more exciting. Now, when you multiply the right-hand side by -1, can you describe what has happened? Well, this point B is reflected about the x-axis. And since you have 1, 0, and the reflection there remains the same. So your new turning points are 1, 0, and remember the x coordinates remain the same, just the y coordinate is, let's say, you can approximate that. If that is your original turning point, the coordinate there, you can guess the coordinate, which is, that is the coordinate there. You can guess that to be maybe 9.5. Oh, we are slightly off. Okay, 9.48, 9.5. That is your coordinate. Make that B. Well, we know that B is 1, 0, and that is your coordinate. Right, so sketching the graph is one aspect, a very important aspect of the graph, of the work. But answering questions of this type, if you multiply by -1, what are the new turning points? You must be able to read them all using the process of reflection about the x-axis. Right, let's see if we can use this principle and see what the question was. Question 11. We're just going to discuss it and I'm going to give you an overview. Right. Let's see here, to work this problem out. Given this cubic function, ax cubed plus bx squared plus c plus 0, right? Because the graph passes through 0, 0. Therefore, there is no constant there in the cubic function. The graph cuts at this point here, 1, 2, 3 roots. But the stationary points are -1 and +2. Okay, let's complete reading this. The graph of g of x is equal to ax cubed plus bx squared plus cx. The cubic function having the y-intercept of 0 is drawn below. The coordinates of the turning points are at x equal to -1 and at x equal to 2. Right, now for which value of x will g increase? So the stationary points are important and always start from the left. Coming down, the function is decreasing, and from x equal to -1 in this interval, the function is increasing, and thereafter for x greater than 2 it's decreasing. The next question will be for which value of x and g, it's about concave. Now for for concave function, we discussed finding second derivative. And there the other questions on this cubic function. Now what I want to do is go back to this graph and show you the purpose of this. It's called a sketchpad, geometry sketchpad. You should do your work and check. At the university, I think you have a maths lab or a few other applications. Can't remember. I know the one is a maths lab. In some students in schools use GeoGebra. So you have tools to check whether your answers are correct. So when you made a mistake, you can go back and check. Right, and this is a cubic function. Just want to demonstrate other functions. Let's see what we have. What are the new functions? Okay, let's see what you got. Y equals sine x, cosine x, tan x. And you also have absolute values, finding the square root, a ln function, and logs, and so on. Just look at the square root function. Let's find this. Let's look at the square root function. Right, f of x is equal to the square root of x. Let's plot this function. There's it here. This is the square root of x. It shouldn't be a dash line, decline. Okay. Now, a function is one-to-one or many-to-one. I'm just going to give you an overview of functions. So y equals square root of x is one-to-one. Now, one of the easiest tests to do is use the vertical line. If the vertical line cuts the graph at one point, it's a function. And let's look at the. What about the horizontal line? We'll cut at one point as well. So this is a one-to-one function. So functions are one-to-one and many-to-one. What about, let's quickly show you another one. The cubic function. Let's look at x squared. Right, now the x squared, the vertical line cuts at one point, right? Anyway, but the horizontal line cuts in 2 points. Not very horizontal, you can always do this. Okay, the horizontal line cuts in 2 points. So this is a many-to-one function. The function y equal to square root of x is one-to-one. The vertical line cuts 1 point, the horizontal line cuts 1 point, it's one-to-one. So it's a very simple technique to determine the function. And so if you have the graph sketched, it's so easy to say it's either one-to-one or many-to-one. Now, what about this? If you draw a circle, the vertical line will cut in two places. So straight away it is not a function. The graph of this is x squared plus y squared equal to 16. The vertical line cuts in two places and the horizontal line cuts in two places. So start with the horizontal first. 2 cuts in 2 points and the vertical in 2. So this is a non-function because it's a many-to. It's a many-to-many mapping, and that's a circle which will reduce to a point. All right, so we're going to go back to the let's go back to this square root function, the root function. The domain is from 0 to infinity, right? So as x increases, you can say it increases, right? So the domain is from 0 to infinity. What about the range? Now you notice the graph is above the x-axis. So the range is from 0 to infinity. Go up that way. So you get questions on domain, range, etc. Now let's adapt this or modify this equation here to let's say what happens if it is square root of x minus 2. Let's say you want to find the domain of this. So this new function has moved 2 units to the right. So if you have y equal to f of x equal root of x squared, then x minus 2 will shift 2 units to the right. And shifting principle is very important. It makes the work task easy to sketch graph using shifting principles and reflection about the x-axis and y-axis. So the domain of this is x greater than 2 because this graph has shifted 2 to the right. Let's multiply. Oh, the other point is why is this graph above the x-axis? This is because the square root of a number is always positive. This is a positive square root. Let's multiply this by, say, minus 1. Square root. Say minus 1. Oh, can you see that? By multiplying by minus 1, this is a reflection about the x-axis. This is not telling us that you can find the square root of a negative number. or the square root of a number that's negative. But if the square root of a number is positive, but you multiply by -1. Now, the range of this is, the domain is from 2 to infinity. The range is from, the range is y is less than 0. The range is negative because you're taking you multiply the root by -1. Okay, some few techniques there. You start with the square root of x. For x minus 2, you shift 2 units to the right. What about x plus 2? Let's say x plus 2. This graph here has shifted 2 units to the left. So that principle is very important. You have the square root of x. If it's x minus 2, it shifts 2 units to the right. And square root of x plus 2, the graph shifts 2 units to the left. Keep that principle in mind and apply them wherever the situation or the opportunity arises. Next, we look at the parabola. Right, this graph is y equal to x squared. Let's look at x minus 3 all squared. There you are. That was your original graph y equal to x squared. Right, so if you were given to draw the graph of x minus 3 all squared, there's a graph of y equal to x squared, which you already know. What happens is, okay, this point is 0, 0, and the 0, 0 moves 3 units to the right, which is 3, 0. Let's take this point here, which is 2 squared is 4, 2, 4. Move it 3 units to the right. Okay. Okay, another technique which I will recommend for students is the line of symmetry. The vertical line. Let's look at the vertical line there. We don't want to spend too much of time doing calculations. We want to find quick, easy ways of sketching graphs. Right, y equal to x squared, the y-axis is the line of symmetry. As explained in the previous example, for x minus 3, you move each point on the graph 3 units to the right. But here we can use the line of symmetry, which is now x equal to 3. Right. And So your turning point is 0, 0. So your new turning point is 3, 0. Your new line of symmetry is x equal to 3. So straight away you got, and all you need is one more point. And if you want, take 5, substitute 5 minus 3 is 2, 2 squared is 4. Right. Okay. So you got your vertical line, which is a line of symmetry. You got your turning point, and you've got the point 5, 3. And using reflection, that's the point of reflection there. So given 3 points, it's so easy to draw the graph and using the line of symmetry. Okay, what happens if you multiply this by, let's multiply the right hand side by -1. Minus times x minus 3 whole squared. There you have this new function. Right. So we all know how to draw the graph of y equal to x squared. Then you have x minus 3 all squared. You shift it 3 units to the right. And if you multiply by -1, it's a reflection about the x-axis. Okay, that's an overview of functions. You can talk about domain, range. And I always tell my students, if you draw the graph, it's so easy to write down domain, range, etc. The last one, the range is from 0 to y is less than 0, y is negative. It is a many to one function. The vertical line cuts at one place. Okay, I think we just have to touch on one more before we break. Well, there's absolute values. I'm not going to go to that one. Square root. Okay, let's look at 3 divided by x minus 2. Okay, this function is as an asymptote. You can call it an hyperbola. And I think it's useful to. Now, remember, you got x minus 2 in the denominator. Therefore, x is not equal to 2. And it's important to show it on the graph that x is not equal to 2. So that is what we call an asymptote. We need a dash line for that. Okay. Right. So with the hyperbola, you get two branches. And here, I don't know, you can call it like, it's in two pieces because it's separated by the asymptote. Asymptotes are very important. There's the asymptote. X is not equal to 2. Okay, I'm going to stop at this point because I need to go for a funeral a bit late. Okay. Can Rachel or someone take over for the next few minutes, please? Appreciate it. Or if you have any questions, we'll leave you in the capable hands of Rachel. Thank you.
Hi, I sent a message over chat.
Could you just repeat it?
Yeah, I asked, I have a really bad signal right now, and like the latency is so bad. So every time he explains something, it gets cut off and it doesn't match with the thing that he's displaying on. So if it's possible, if I could get the recording of this. I'm sorry, I can't hear you.
Just the recording will be made available for all the sessions. We just need to get the link, and I'm sure we can send it out to everyone.
Oh, okay, thank you so much. My exam is tomorrow, so would it be sent out before that?
Yeah, I can talk to the person in charge, and we can see what we can do. I'll actually just send an email now.
Okay, thank you. I did send my my email on over chat.
I'll just write it down.
Do you want me to give it to you again?
No, I've got it. It's just the previous question got erased when the power tripped. So, since you're the only one here, do you have any last minute questions before the session ends?
I have had like a really hard time navigating through functions. I've had it like, so I completed Matric last year, so I'm writing the supplementary for math now. And even during my exam last year, I had a lot of issues with functions. I guess just understanding it in general was a bit of an issue for me. And then now, as he was explaining to me, I kind of understood it, but
I think you're breaking. Okay, so we've lost our last student. So the recording link will be made available, I'm sure, in the next session, or it'll be sent out to you. So don't forget that we still have more sessions for physics, chemistry, life science, and maths. I'm sure everyone has that pamphlet that got sent out with the meeting links. So just remember, Saturday, 9 to 12 and 3 to 5 will be the next math sessions, along with today from 5 to 7.